Hi, welcome back to our channel and back to the tutorial for deep learning. Today we are going to continue the session, that is how we can achieve image segmentation with the help of AutoUnit here. The previous lecture I given information about the basic information about the AutoUnit, what is AutoUnit and why we need the AutoUnit and what are the advantages including the disadvantages at last application to here. Here we are going to see the image segmentation. That means we are taking the sample images from the benchmark dataset, affected kidney images, just showing example for the purpose of AutoNet. And first of all, we are going to implement the AutoNet and show the difference between the original image and the predicted or mask segmented image. Then we are going to highlight the affected area with the help of red color and so on like that. So AutoNet is one of the familiar and successful network and having lot of features, especially it combines the UNet, RNet and sorry, UNet and some other features also here. So here for this one, there will be some steps there to achieve the image segmentation. That means particularly the diseases are affected image affected area from the given image. For this one, first of all, we have to install the packages. Then we have to add the recurrent residual connection block. Then we can add the another block for continuous operations. Then move for the image segmentation, where we are going to discuss about the input functions. Then resize the images and go for the visualize the output here. These are steps required for achieve the image segmentation. So we introducing the CV2 for image reading and resizing. Then we are going to implement the NumPy as NP for numerical operation. Then we are using the TensorFlow for train the deep learning model and using the matplotlib pilot as we need for visualize the results. That means images results also. Then we are adding the recurrent residual connections, sorry, convolution block. For this coding, definitely helpful to apply the convolution function. And also, if you have iteration of I iterations or T iterations, here the output of the X, previous output of X1 connected to the input of the another one, another X like that, and continuations going on for get the or achieve the recurrent residual convolution mask block. This is the OLAP video. We are going to help to achieve the medical image segmentation task because these are very tough and complicated. And we are adding the block. We are going to add the block one, recurrent block one, and block two for achieve the binary classification method here. That is 0,1 method. Then we are define the AutoUnit model here. And we are going so after definition of model, we are going to give the x1 as y1 as and x2 y2. Then we are giving the encoder decoder as we discussed in the architecture. So encoder here one helpful to always come with the downsampling function with the max pooling and so on, and helpful to extract the complex features, and decoder helpful to reconstruct the image from the given features like that. What are the complications or complicated things? Everything is solved with the help of this encoder, decoder, and with the help of skip connections here. And output is there where we are writing the output for achieve the binary classification and view the output and load the model. And we are going to pre-process the one and predict the segmentation. For this one, we're writing the function called segment under image of image path. So for this exercise, if you want to do means you can download the image and save in the Google Colab G drive. Then we can give the path here. So we are going to use a predict mask and followed by a plot, sorry, plt.figure, and size we are considering consider say 10,10, and original image is there. Then we are following the segmented image. We are using the RGB image format, so we can get the color image as output. Sorry, gray color image as output here. So at last is visualize the original image along with the segmented with the values like that. So like that we can achieve the AutoNet for image segmentation, and we can go for highlight the affected area. For this one again we are adding the libraries, required libraries. Then we are using the function recurrent block function. There we are going to add the block. Then we are implement the model. We are using the AutoUnit model, then encoder, same decoder, and outputs. And we are going to load the model. This is very important. Model is called AutoUnit underscore model. So whatever the deep learning model you're going to train, it will helpful for you. Then highlight the affected area in red color. We are writing the code, right? That is image resized, followed by the image input, np.expand dimensions, and writing like this code. It will helpful to create a red color mask along the in the images, affected area, even the corners also. And we are apply the new highlight area, then followed by display results told no just now. So visualize the images, then go for the predictive mask, at last go for the highlight effect area and test with the image. So it automatically save the image and display the information if your goal of coding is correct, alternate coding. So first of all, showing the original image and showing the predicted mask, at last showing the affected system kit image with red color along with like this. So I hope that today understand how we can achieve image segmentation with the help of, that is especially medical image segmentation with the help of AutoNet and so on. Thank you for watching the video. If you like the video, please subscribe, share with your friends. Thank you for watching the video. Thank you.